This presentation is 2020 Wildfires and Exceptional Events, presented by Matthew Densberger of the California Air Resources Board.
Hello everyone, I'm Matthew Densberger from the Air Quality Analysis section of the California Air Resources Board. I'll be speaking about some of the air quality impacts we saw in California from the extensive wildfires in 2020, and an overview of the exceptional events processes that we undertake here at CARB. The preliminary chart here on slide 2, originally tweeted by CAL FIRE in October 2020, shows the largest historical fires in California based on acreage burned at that time. By the end of 2020, the August complex covered over 1 million acres of land, while the Creek Fire moved up to 4th place, and the SQF complex joined the chart in 18th place. Needless to say, 2020 was truly a historical year for wildfires across California, and 2021 has been extremely active as well, with the Dixie Fire now in 2nd place for California wildfires. Based on CAL FIRE data, there were 15 wildfires, each burning more than 50,000 acres in 2020. These large wildfires extended from the Oregon border with the Slater wildfire in the Klamath National Forest in the north to as far south as the Bobcat Fire in the Angeles National Forest near Los Angeles. Overall, there were nearly 10,000 fires tracked by CAL FIRE and federal services, covering approximately 4.2 million acres of California. Or to look at it another way, about 4% of the state had burned in 2020. This was a massive increase compared to 2019, when less than 260,000 acres burned, and about 3 times the amount of acres burned in 2018, another significant wildfire year. Here, we have NASA imagery from MODIS instruments on the Terra and Aqua satellites. In these images, smoke generally shows as a brown-gray or off-white color with a wispier texture, as compared to the brighter whites of snow or clouds. The areas marked red are where MODIS detected potential fire anomalies. On August 20th, we see multiple large wildfires in California with smoke covering much of California, being blown over the eastern Pacific Ocean and across much of the western United States. The smoke in this image extends from over 500 miles to the southwest of Los Angeles and eastward across parts of 12 states. In October, smoke can again be seen extending from the Pacific Ocean across much of central and northern California and into Oregon and likely southeastern Washington and Idaho. There were many days in the summer and fall of 2020 where the wildfires in California, Oregon, and Washington blew hundreds of miles away, with some areas being impacted by smoke brought down to the surface. CARB has published draft wildfire emissions estimates, which show 2020 to be a truly historic year. This figure on the slide shows the annual wildfire greenhouse gas emissions in California since 2000, with preliminary emissions included for 2020. Last year's emissions were nearly 3 times those of the next highest years in the 2000s. Profound impacts from the extreme emissions were felt by people across California and large portions of the western United States. Emissions from wildfires can contain a large variety of dangerous compounds that impact people, animals, and plants. We will focus our discussion on fine particulate matter, or PM 2.5, and ozone, both of which can be dangerous to children and adults by causing damage to the lungs and cardiovascular system, among other problems. Fine particulate matter is emitted directly during wildfires, as well as formed during secondary chemical reactions of emitted gases, such as sulfur dioxide, nitrogen oxides, and other organic compounds such as VOCs. PM 2.5 can also be transported over long distances and be seen on satellite imagery. Ozone is a secondary pollutant. formed when wildfire emissions of nitrous oxides and VOCs react with sunlight. This is an extremely complicated process where wildfire smoke can both promote or inhibit ozone concentrations depending on a number of factors, including plume chemistry, smoke thickness, and time. Ozone concentrations at the surface can be impacted through horizontal transport and vertical mixing, bringing air masses with higher ozone concentrations from higher altitudes or more distant wildfires to ground level monitors. Now let's take a look at how the 2020 wildfires impacted PM 2.5 for several major areas in California. During a normal year with no major wildfire impacts, such as in 2019, August and September are normally the cleanest months for PM 2.5. Conversely, large wildfires occurred in both 2018 and 2020, which resulted in significant impacts across the majority of California. As shown here, wildfire smoke contributed to higher concentrations and exceedances across much of California in 2018, while even worse in concentrations and coverage in 2020. In the first few weeks of the firestorm in August 2020, about half of California's population, an estimated 19.6 million people, experienced levels of fine particulate matter exceeding national ambient air quality standards. By the end of September, the smoke had spread across Southern California and to nearly every corner of the state, with almost 95% of Californians exposed to unhealthy pollution levels. Monitoring data showed that 15 of the top 20 fine PM readings on record in California had occurred during the fires in 2020, as of 2020. The highest concentration was on September 15, 2020 in Mammoth Lakes, where the daily averaged PM 2.5 concentration reached 660 micrograms per cubic meter, more than 18 times the federal health-based standard of 35, and beyond the range of the Air Quality Index. Please note that this slide does not include any data of the fires from 2021. These calendars are of observed maximum fine PM concentrations in the Sacramento Valley during the typically clean summer PM season, such as can be seen in 2019. In stark contrast, 2018 shows periods of very unhealthy values occurring in late July into early September, and again in November in 2018 due to wildfire emissions. Then in 2020, smoke impacted fine particulate matter concentrations during a prolonged period from August to early October. These periods are the direct result of large wildfires occurring in California, emitting large amounts of smoke that impacted locations across the Valley region. Now we'll take a look at how the wildfires impacted ozone concentrations in California. Looking at ozone in the Sacramento metropolitan area, 2019 represents a more typical year for when there are no significant wildfire impacts, while 2018 and 2020 have more days with exceedances due to influence by wildfire emissions. While the summer months are typically the high season for ozone, the purple, very unhealthy days shown here are not normally observed in the Sacramento summertime, yet did occur in both 2018 and 2020 during periods of wildfire smoke enhancing ozone values across the region. Generally, the San Francisco Bay Area has typically lower ozone values with only a few exceedances each year. However, in 2020, elevated ozone concentrations occurred during August to October when wildfire smoke impacted the area. Now that we've seen a little about how 2020's wildfires impacted PM 2.5 and ozone, we'll touch on the federal exceptional event process. For a quick overview, the district must flag data and inform CARB and EPA of the event's impacts through submission of an initial notification form to CARB. Please contact CARB or EPA Region 9 for the initial notification form and guidance on how to complete it and any questions you might have. CARB staff will be able to review the information and forward to EPA if agreed upon and complete. EPA then will determine if there is a need for an exceptional events demonstration and advise accordingly. If a demonstration is concurred with by EPA, the event-related data is flagged further by EPA to be removed from the design value calculations in AQS. In 2007, the exceptional event rule was laid out in the Code of Federal Regulations, Title 40, Parts 50 and 51, which sought to provide a path to exclude some influence data from specific regulatory determinations. In 2016, the rule was further revised to address issues and streamline the process for many situations. The regulatory decisions that can apply to an exceptional event demonstration are limited to the designation or redesignation of an area, the classification of an area, the attainment determination for an area, affecting an attainment date extension, a finding of SIP inadequacy leading to a SIP call, or other, which is discussed with EPA on a case-by-case basis. However, none have been attempted as an other type category, and I am not aware of any examples that have been considered by EPA. Current EPA guidance has specifically stated that exceptional events cannot be used to exclude or modify data for modeling analyses, satisfy regional haze requirements, limited maintenance plans, monitoring and sampling requirements, satisfying data completeness, nor emergency episode planning. For the exceptional events process for wildfires, there are two types of flags used. In most situations, all data that is believed to have been impacted by an exceptional event should be flagged with the informational IT Wildfire US flag to note that the district believes that the data was impacted by wildfire emissions. CARB suggests the IT flagging to be done even if there is no regulatory impact at that time. When flagging, the data should be flagged based on the level of the standard. Later, after discussions with CARB and EPA, if EPA requests an exceptional event demonstration, then flagging the data with the request for exclusion RT flag in AQS is necessary. Data that has been requested will show up as lowercase rt in AQS until EPA concurs with the demonstration. Once concurred upon, the data will show as uppercase RT next to the requested data and will be excluded from applicable air quality calculations. I'd like to note a few key points for flagging exceptional events. When an event is ongoing or shortly afterward, it is ideal to flag the data with an informational flag and note the event cause, such as using the IT Wildfire US flag and noting that the data was believed to be impacted by wildfire smoke from a specific fire, such as the car fire as shown in the example here. Later, it is often difficult to determine that data may have been impacted by an event unless it is an overwhelming and obvious widespread event. So smaller localized events can be easily overlooked if it is not initially flagged and noted well. Additionally, data flags are necessary as part of the exceptional event process. While flags can be added later, any look-back analysis may only cover a small subset of the data or be missed entirely. Even if there is no immediate need for an exceptional event demonstration for the site, the data may be reviewed later for a regulatory decision where flagging would help in finding data that may have been impacted by events. The exceptional event process requires that EPA be formally notified with an initial notification. Initial notification forms have been developed and are available from CARB or EPA Region 9. These forms are specific to the standards and design value year. I&I forms must be submitted to CARB for review, which then forwards complete and agreed upon forms to EPA Region 9. EPA then has 60 days to respond, where EPA will typically go down one of three avenues. They may request further documentation for a full demonstration, seek a meeting or call amongst the requesting parties, or defer for further review. Deferring is generally the result of a request not having an immediate regulatory impact, but acknowledging that there could be a need at a later date and thus putting the request on hold. Should an exceptional event demonstration be requested by EPA, then analyses and discussions will need to be completed and submitted to EPA. The demonstration document requires a narrative conceptual model that describes the events, a demonstration of a clear causal relationship between the event and air quality, comparisons of the event data with historical non-event data, a demonstration that the event was not reasonably controllable nor preventable, show that the event was caused by human activity that is unlikely to recur or that it was a natural event, and evidence that an air agency followed the public comment process before submission of the demonstration to EPA. The quantity and detail of analyses and discussions vary based on the standard that was impacted and the obviousness of the events impacted. A summertime wildfire PM 2.5 demonstration would be generally shorter with a simpler documentation and analyses for a site that hasn't exceeded the standard in recent years, as compared to a summer ozone demonstration at a site with common exceedances, which is much more complicated to prove. Wrapping up, if you have any questions for PM-related events, please reach out to my colleague Teresa Najita, who is also our next presenter. For ozone, please feel free to contact myself at the email above. The provided links include more information into ongoing ozone exceptional event activities at CARB, as well as additional information from EPA on the exceptional event rules, guidance, and approved demonstrations. Thank you for your time and have a great morning.
We will now be entering into the Q&A discussion portion. Please type your questions into the Q&A chat. Matthew, if you could join me on screen, please.
There we go.
Give everyone a few moments, type their questions into the chat. Please note you can type your questions in at any point in time during the presentation as it is playing as well for this and all future presentations.
Looks like a fairly quiet morning.
Yep. We do have one question. How does CARB decide whether they will be involved in filing for an exceptional event?
Primarily, it's driven as to whether the event would have a regulatory impact. We'll go through our own analysis and determine whether we believe there's regulatory impact, as well as what potential ramifications it would have, and if EPA, if we determine that there is regulatory impact, we'll reach out to EPA and start a discussion with them as well and move along.
All right. Would tribes submit an initial notification form directly to EPA, or would they go through CARB?
Good question. I have not been a part of one yet, or heard discussion. I believe they can reach out directly to EPA, but we would also work with them as well, I believe.
What serves as proper documentation to prove a wildfire?
It can be a large number of things. Primarily, it's driven by the data at the site. If we're lucky enough, there'll be PM data at the site as well, perhaps speciation data, such as levoglucosan or carbon or black carbon, and that would help reinforce the argument there. We'd also be looking at satellite imagery, the weather in the area, and running trajectories. If it's a more difficult one, it can require modeling and more advanced forms of regression. Definitely more time consuming when you reach those steps.
All right, thank you. Unfortunately, that's all the time we have for Q&A at the moment. Before we move into our next session, Matthew can provide his contact information in the chat, and you guys can contact him later. Thank you, everyone, for being here.